Hello, welcome to DBK Consult. Our custom here is picking out a piece of architectural drawing and walk through the processes of how you can come up with a suitable and cost efficient design with due regard to safety and detail it which the artisans can implement while on site. So this is the current model we've been working on, and these are the views. Our previous class, we saw how we can model our structure up to the level of this first floor. All right, this is a four-story residential. That means we have our ground floor and we have four other suspended floor. All right, and we said our ground floor is a car park. Just to have a walkthrough on what we are modeling, we said our ground floor is a car park. Then our first and fourth floor are similar, and the second and third floor are similar. All right, after making the general arrangement, we agreed that this will be our ground floor structural layout. So these are the columns we exported to our Prota-Structure for modeling. All right, why this is our first floor structural layout. So this is what we'll be able to model on Prota-Structure: our columns, our beams, and our slab. All right, so we have to work on the next floor. If you've not subscribed to our channel, this is the best time to do so, and turn on the notification bell so you get notified anytime we post new videos in this series. Do not forget to like if you find this video helpful at any point. So to insert our next story, let's come down here and count the number of stories we have to insert. All right, so I will minimize this and come to my Revit model, and as you can see, we have a G plus 5 as earlier said, a G plus 4 as earlier said. So this is 1, this is 2, this is 3, this is 4, and this is 5. All right, so we'll be inserting 5 stories on this model. So let's come back to our Prota-Structure, and we come to, let's take this to the plan view, and we'll come back to our building setout, and in this place we click on insert stories. All right, so we insert a total number of 5 stories as we've counted. So we'll click on, we'll type 5 over here. All right, and yeah, we have story 1, 2, 3, 4, and 5, and this place is for our foundation. All right, so we'll be leaving this part for now. So currently we have to start working on our story 2. All right, so to do that, when we move from the ground floor, which is our car park, onto this first floor, all right, for some reasons we have to rotate this column to 90 degrees against what was coming from the ground floor. And if you look at this, let's make a copy of this column that was coming from the ground floor, and let's copy this to the architectural drawing. All right, so let's copy from grid line 3 and grid line B asterisk. All right, so if you come here and copy, and we'll take this to our ground floor structural layout, our ground floor architectural plan, you will see that this column is intercepting with our windows. Okay, so we have the options of either reducing the size of this window, or we reduce the size of this column to suit. All right, and the decision we made is we can take this column to this point when we get to the first floor. All right, considering the fact that it is not affected on the ground floor since it is a car park, so we decided that getting to the first floor we have to rotate this way, so we can as well maintain the reason behind this void. All right, the void was created for proper lighting and ventilation, but if we have to take this column to this point, then we are in turn defeating the idea of creating this void in the first place. Now, while you are making this decision, you should ensure that this has nothing to do with your structural integrity, and by experience you will see that this will actually affect the structural integrity of this very building. Now, if you come here, the moment we switch our, this is not a very good practice in structural engineering, because the moment we switch our column from this part, from this orientation to this orientation, it immensely changes our neutral, it immensely changes our major and our minor axis by 90 degrees. So what it does is when the load is being transferred, the major and the minor axis of these columns will change at that very point. Okay, so if we have our major axis here, on getting to the first floor, our major axis will change to this very direction. Okay, so this is not a very good practice in structural engineering. It is advisable that you maintain your minor and your major axis. All right, so what we'll do is we'll go back to our Prota-Structure, and this column that we intended to rotate to 90 degrees when we get to the first floor, we can actually start this from the ground floor. All right, we can actually have this orientation from the ground floor in order not to change this major and minor axis. So that is one modification we will be making to our Prota-Structure, and we'll be doing the same thing to this point. Okay, so the reason behind creating this at this point was, if you copy this to our architectural layout, you will get to find out that when we get to the first floor, these columns, if we continue these columns at the first floor, it will go into our living area. All right, it will go into these two living area. So we also said on getting to the first floor, what we'll do is we will rotate this column as 90 degrees. And like I said earlier, this is not a very good practice in structural engineering. All right, so we'll have to start this column from the ground floor, and it will come at this orientation from the ground floor. All right, so I will come back to my Prota-Structure. So coming back to our Prota-Structure, we are speaking about these columns, right, which is interfering with this living area, and this which will be interfering with these windows over here and over here. All right, now bear in mind that if we had no window running here and we had no window running here, this will be the preferred method of positioning our columns. Right, now why would this be the best method of positioning our columns? Because during construction, if we run a line, if we get this point and we get this point, all right, and we also come to the last column, then we get this point and we also get this point, all right, we can run a builder's line all through from the top to the bottom. All right, and automatically our columns in between, which is this and this, we have to align to our builder's line. So it makes our construction processes easy by keeping them in a straight line. So this is very important. You should also consider the ease of construction while you are designing. All right, but none of this should be as important as the integrity of the structure. All right, so the integrity of your structure, the safety of your structure comes first. So for the reason of us not changing this major and the minor axis, we have to reorientate this. And let's come to, just click on the column and come to properties. All right, so there are different ways we can do this. We can either come here and we take the dimensions of our b1 to our b2. All right, or we can rotate this by 90 degrees. So let's start with the first option. We'll come here and change this to 600, and we come here and change this to 230, and we update. All right, so we update and we close. So we have rotated this by 90 degrees. Now the next thing we can do is we have to make sure that this column aligns with this point. All right, so we can at least get the straight edges with this builder's line when we align this first column to this last column. All right, so to do this, let's go back to our AutoCAD and come to this point. All right, so we'll be taking this column, which is the discontinuous column, to this point, and we have to dimension this. All right, so we dimension this point to this point, and we have a distance of 185 mm. All right, so we dimension from this edge to this edge. All right, So we have a distance of 185 millimeters. So let's come back to our Prota, and if we come here, we can come back to this part, right click, come to properties, and our E1 will change this to 185 mm, and let's update this. Okay, so we can see we have successfully aligned this to the edge of our wall. All right, so we can go ahead and close this up. So we have made modification to this, and we also do same to this part, which is this. So we have our column coming from having the same neutral, the same minor and major axis coming from the ground floor. So we change this to 230, and here we have to type minus 185. All right, so we'll come here and type minus 185 millimeter, and we update this. Okay, update and close. Okay, so we are done with these two columns, and the next is this. So we come here, right click, come to properties, and we rotate this. Against going this way of changing these directions, these dimensions, we can come here and we change this to 90 degrees, then we update and we close. Okay, so that's another way we can make modification to this. All right, and the next is this. We'll come to properties, we change this to 90 degrees, we update and we close. Okay, so for us to interact better with what changes we are making on this structure, let's take out this beam wall load. So we'll come to beams and we'll select from the first beam, come to the last beam, hold your shift, select the last beam, come to right click, and you delete beam wall load. Okay, so we can better interact with this. All right, so we've taken out our beam wall load. So these are the columns that we've made modification to, which is this and this. All right, now coming back to our floor plan, these are the columns that we've made modification to, which is this and this. All right, then we can choose to go ahead with this column. So when we get to the first floor, what we'll do is we have to reduce this column size to something like this point. All right, so while we are increasing or we are reducing these column sizes, we should ensure that this satisfied both our vertical load. We should not just reduce our column sizes because we want to impress the clients or because we want to show the clients that we can do a very cost-effective design. What should guide our increment or decrease of our column sizes is if it has satisfied the loads that are implied on it. Speaking about the vertical load and also the horizontal loads. All right, so we run our analysis and check if they are not sufficient, then we have no other options than increasing the size of this column. All right, so let's come back to our story one. Let's come here and we have to generate what we have here onto the other stories. Okay, so we can start modeling for the other stories. So we'll come to building set out and we'll come to generate stories. All right, so we'll be have our source model here and we have our target story over here. All right, so we'll be moving what we have on our story one, we'll be copying what we have on our story one to our story two. So this is our source and we'll be targeting our story two. So we want all of this, everything on the story one to be generated to story two. So we'll click this and okay and yes. Okay, so now we have a duplicate of what we have on our story one. So let's come down to this part and come down to plan view. All right, so this is now our story two, and remember we said we'll be reducing these column sizes over here and some other column sizes at this very level. Okay, so what we'll do is let's come back to our AutoCAD and we take a look at the columns we decided to reduce their sizes. All right, so we said we will change this from 600 to 450. All right, so it also suits this line. Okay, so we're working with this and we'll be changing this as well. Okay, so we'll also get to change this size over here and we also get to change this over here. All right, so let's come back to our model, and let's come to this column. Then we'll right click, come to properties, and we change this from 600 to 450, and we update this. We close, and we also have to make this flush with this wall line over here. All right, so we'll come back, and we'll come back to our AutoCAD. So let's come back to our AutoCAD to get this dimension. All right, and if we dimension this part from this grid line to this point, we have a distance of 115. All right, 115 millimeters. So we'll come back to our model, and we come here, right click, come to properties, and we are moving from this direction, so we have to edit this. So this comes to, since you are going up, it goes to minus 115. All right, so we update, sorry, it goes to 115. All right, so we update this, and we close. Okay, so the same as this column over here, we'll click, we'll right click, come to properties, we edit this to 450. We'll start with this. Let's take this to 450 mm. Then we update, and we change this part to minus 115. All right, so we update this and close. Okay, so same applies to, so let's make the same modification to the right hand side. So we'll come here, right click, come to properties, and we change this to 450. Update, this comes to minus 115. Update, update, close. All right, then we also come to this point, click here, come to properties, change this to 450 and 5. All right, so we update this and close. Okay, so this now serves as the structural layout of this very level. Okay, so let's come to 3D view and see what we've done so far. So we have to model up to the last floor before we can come back and apply our wall load, so we can better interact with what is going on over here. Okay, so I will stick with these column sizes at this very level. All right, I will stick with the column sizes on this very level. Now I will be reducing my column sizes at the story 3, and not forget, we have to do our designs and our check before we can satisfy that that will be our adequate column sizes. The column sizes we are making over here are just our presumed column sizes. Okay, if you found this video helpful at any point, kindly like it, subscribe to our channel, and turn on the notification bell so you get notified anytime we post new videos in this series. Do not forget, we get to see how you can design for a raft foundation, and we also get to see how we can design for a swimming pool. And due to the height of our story, there will be need to apply the effect of wind load on this structure, so we get to see how you can properly do that. All right, so kindly like, subscribe, and turn on the notification bell. So I'll be sticking with this structural layout for my story 2. All right, since I am satisfied with this, I will have to as well copy this structural layout onto the next story. Okay, so to do that, I will come to building setup, and I'll also generate story. Then I'll generate from my story 2 up to my story 3. All right, so I'll click OK, and I'll close this. Okay, so let's come back to, so we are currently at our story 3. All right, so what we'll have to do is we intend on reducing these column sizes here from 600 and mostly to 450. Now there are some specific column sizes we do not intend to touch. Okay, so the ones we are not touching are the ones at the edges, the ones at these edges, which is this and this, the ones at the four edges. All right, then also the ones that are supporting our cantilevers. Okay, because they'll be having a lot of work to do, so we don't intend on reducing the sizes of this and the sizes of this. Okay, so we can reduce it at the upper floors, but for this level we still maintain these column sizes. So let's start with this, and we come to properties. All right, so we're changing this to 450, and we update and close. All right, so we'll do this for the opposite side. Come to properties, change this to 450, we update this and we close this. Okay, so we're doing same for this point. Click here, properties, or we can as well select these two columns together. Click this, hold your control, come here, right click, come to properties and click here, column wise edit. Then we change this to 450 mm. Okay, and we close. All right, so we'll be keeping this. Will also be, we can reduce this, all right, because the size of this cantilever is not much. So we'll click on this, click on this as well, hold our control. Okay, we'll come back, we'll select this, still holding our control, we'll select this, we'll come to this side, select this and this. All right, and we also make selection of this and this. So right click, come to properties, column wise edit, and we change this to 450 millimeters. All right, and we close. So now we have to make sure these columns they align with our wall lines, our beam lines over here. Okay, so we select this, then from this point we have minus 185. All right, so update, sorry, we have 115. All right, so we'll update this. Okay, come back here, then let's select these two together and this other two. Okay, we'll come to properties, and on this part we'll be changing this to everything here to 115. Okay, so we close and our columns are aligned. All right, then we'll come back to this and minus 115. This should do. All right, and this as well. Select properties and this changes to minus. All right, and we update and we close this. Okay, so let's see what we have. I think we still have some columns over here, so we'll be working with this, this, okay, then this and this. So we'll right click, come to properties, and we'll be changing this to 450 and close. All right, we'll use same principle for this part. This comes here and this comes here, properties, edit, this changes to 450. Okay, and don't forget we have to align. What we can do is for these ones that are in between walls that will be covered by two walls, all right, we can choose to leave them at their current positions. Okay, so why these ones that will be affected by this living area, that we, if we have to increase this to this part, it will affect this living area, we can choose to flush it with the end of these beam lines. Okay, but for these cases we have to leave it as what it is. All right, so let's go ahead and save this structure. So we are done with saving our structure, and the next thing we'll do is we edit this last column, which is this, and this will come to properties, and let's change this to 450. All right, we close, and this too come to here, properties, and we change this to 450. We update, and we align this part to -115. Update, close, we come here and we repeat same thing, come here, properties, and change this to 115. All right, so we update this and we change this to 450, updates, and we close. All right, so with this we should be done with our column sizes for this level. All right, so let's go ahead and check at the edges. So the reason why we are keeping this column at the edges is not mainly because we expect it to carry much load than these other columns, all right, but it's just for us to maintain, like we said, it will be easier to maintain this straight line, maintain the aesthetic of this structure, because we will have our builders line always running from this edge to this edge. Okay, so every other thing can align from this face coming to this other part. Okay, so that is why we are maintaining these very column sizes from the ground floor and possibly to the apex. All right, so that's the reason behind keeping this column here, and not necessarily because it is carrying much load than the column at this very point. Okay, so let's come to that understanding, and I believe we are done with the columns that should be changing from 600 to 450. Let's reduce our beam sizes. Okay, so the beam sizes at this level is still our 230 by 600 thickness. Okay, so let's take this beam depth to 500. Okay, against 600, let's reduce our beam depth to 500, and to do that I will come to beam. All right, then I will come to summary table. All right, so you can see our width, all our width here is 230, and all the thickness here is 600. Okay, so I can click here and click on column wise edit. All right, so I will change this to 500. Okay, and all right, so we've reduced our beam sizes, and if you can see, we have here 230 by 500. All right, so let's duplicate this to the next level, and we'll come to generate story, building set out, generate story, and we are generating from story 3 up to story 4. Okay, and we are generating everything on this model. So we'll click OK and yes. All right, so automatically that's taking us to our story 4, and let's see what we've created so far. So gradually we are coming to the conclusion of this structure, and at this level we also have to reduce our beam depth. So at this level, let's take our beam depth from 500 to 450. All right, so we'll come back here and come to beams, right click, come to summary table, and over here we'll be changing this to 450. All right, and we'll click and we'll close this. Okay, so on our story 4 we have 450 by 230. Okay, so we can as well reduce the column sizes, some column sizes on this very level. Okay, so we can choose to take this to 450. All right, and if it passes our, we can choose to change this to 450, and via these internal columns we can attempt to make them 300. All right, 300 millimeters. Okay, and always keep in mind that structural integrity is number one. This is subject to change as regards to analysis and design. Okay, so what we'll do is we'll come here and select the columns we intend on changing from 450 to 230. Okay, so we'll start with this one, this two. Okay, we'll select this as well, and this, come to properties, and we'll be changing this to 300. Okay, and this should align. So this should align from, let's take up our calculator, and over here we have 450 and it's changing to 300. All right, so we'll take out minus 115, and what we have is 35. All right, so we'll come back here and come to properties. So we'll be changing this from 115 to minus 35, and let's update this. Okay, and we'll close. Okay, so we'll make same modification to this, this, and this. All right, come to properties, and we'll be changing this column to minus 35. Update, close. Okay, so we'll make modification to these two as well. Select this, 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 and this over here. Come to properties. This is changing from 115 to 35. Okay, and we come back, properties, also changing from 450 to 300. Okay, so we are almost done. All right, so we can as well make modification to these two columns. Okay, so we can still use this point to align with our columns. All right, so we'll make modification to these two, and as well these two. Okay, and we'll be keeping this that is carrying our cantilever. Okay, or we can as well reduce the size to 450. We are just trying as much as we can to as well manage the cost of construction, but in no time are we playing with the integrity of this structure. So we'll come back to here and we change it from 600. Come to column wise edit, and we'll be changing this to 300. All right, okay, and this part changes from here to minus 35. Okay, so this has aligned, and the other two will change from minus 35 to 35. All right, so we'll come back here, come to properties, and let's keep this as 35 millimeter. Okay, and close. All right, so we'll be keeping this at 450. Come to properties, and this is changing to 450. We update, and this is changing to 115. We update, close. Same as this, properties, 115, 450, update, and close. Okay, make modification to this part here, and this properties, this changes to 115. Okay, and this part changes to 450. Okay, and close. Sorry, minus 115 properties, and we change this to minus. Okay, let's change this to minus 115. All right, and we close this. Okay, so next is this and this, as well as this and this, and we will not be touching the eccentricity of this one. We will just have to change it to 450 and leave it at the center. Okay, we will leave it at this center point. All right, so what we'll do is we will be sticking with this, and you can go ahead to edit further, but we'll be sticking with this for the reason of this tutorial, and we'll come back to building setout, and we'll generate story from here to the last story. And in this case, we have to take out everything as regards to our slab. All right, so we take out all our slabs because the slab level is not, the roof level is not slabbed. So yes, close, and let's see what we've done. Come to 3D. All right, so this is what we've done so far, and we'll come back to our plan, and we'll be inserting a slab at this very point, okay, on our shear wall. Okay, so what we'll do is we'll come to slab, and we'll stick with the, okay, this is not a cantilever, so we'll take this to type 1, and we'll stick with the previous properties. Okay, so we'll come here and we'll place our slab over here. All right, so keep in mind that at this point, over here, we need to provide a cantilevered beam. Okay, we have to provide a cantilevered beam that will carry the roof that is coming at this very point. Okay, remember, this is a cantilevered slab, so we have to protect this place by a beam in order to carry the roof coming at this very point on the roof level. Okay, and to do that, let's keep in mind that our beams or our cantilever has a width of, has an L count of 1.2 meters. Okay, so we'll come here and we offset axis, we'll coming towards this direction. So we'll type F2, we'll press F2 on our keyboard, and we'll type -1 200. Okay, enter. Come back to this point. We'll also offset to this part, offset axis, come here, and we F2 -1 200. Okay, and we enter. All right, so the next thing is we'll come here, come to properties, and we'll draw a beam from this point to this point. All right, we'll also draw from here to here. Okay, we'll draw from here to this point, and we'll draw from here to this point. Okay, so we can join this will cantilever, we'll join these two from here to here, and finally to here. All right, so let's close this and come to 3D, and this is what we've achieved. So let's come back to plan view, and we create same scenario for here. Okay, so right click, come to properties, and we maintain cantilever this. Ensure the ones coming from the columns are the ones that are cantilevered. All right, so we'll cantilever this as well. and this. So we'll join this and we can cantilever this. Okay, we'll join and we'll join. All right, so we'll do same for here. So the next is this. All right, we already have these beams cantilevering from our first floor level, so we just have to join this to this and this to this and this point, then lastly this point. All right, and we'll be making more changes to this floor level. So we'll be changing these beams from 450 to a depth of 300. All right, so let's come back to our beams, select from the first beam to the last beam, and we come to properties. Okay, so we'll click here and all our thickness is 450 millimeter. So we'll click on here and come to column wise edit, and we change this to 300 and okay. All right, and we can close this. Okay, all right, and the next thing we have to do is we increase or we add our beam wall load. All right, so we have to add our beam wall load at this point. Remember, this was taken out so we can better interact with this structure visually. Okay, so we'll come to our story one and we'll come back here. We'll click on any of the beam, we'll right click, come to edit beam wall load, and we change this to 2.87. all right, and our wall height and our wall thickness is 230 millimeters. So we will be typing 0.23. all right, and if you see over here, our dead load according to the wall, all right, has already been calculated. So if we change this to 3, you will see the value here is changing. Okay, so come back to 2.87. all right, and we'll okay, so we'll come here and we'll copy beam wall load, then we'll select all beams on this story, right click, and we'll come to paste copied beam wall loads. all right, so we'll paste this and let's see what we've done. all right, we've done this in the last lecture, and you can see our wall load has been applied. Our wall is now applied on this story. Okay, so we'll come to story 2. Okay, and we'll come to beams, right click, or you select this and come to the last one, right click, paste copied beam wall load. Okay, so we'll paste and you can see our wall has been generated. all right, we'll do same for story 3 beams. We'll select the first beam, come down to the last beam, right click, come to paste copied beam wall load. Okay, so you see it has been included. And the next story 4, all right, and we'll come to beams, select the first and come to the last, right click, paste copied beam wall load. all right, so you can see we have inserted our wall load on this structure. all right, so we are done with modeling this structure, and the next thing we have to do is the pre-analysis. all right, so our next lectures will be pre-analysis, and in this series of lecture we said we'll be designing for a raft foundation, and also we'll be designing a swimming pool. And keep in mind that we also get to learn how we can properly apply wind load to this structure. all right, so if this video has been helpful to you at any point, do well to like it, subscribe, and turn on the notification bell so you get notified anytime we post new videos in this series. all right, so see you in next class.